Hello, hello, hello. Welcome back. So today, let's see what we're gonna do. We're gonna go back at this thing. We've done this before. We're gonna go back. We're gonna try a few things a little differently than we've done before, from an AI standpoint. But the embedded standpoint, we're gonna cheat. I've already got a working example that we did, and I'm gonna try to use the AI to update example to go do something a little bit different. But we're gonna use few different things with Claude Code. Or specifically, we're gonna use some slash commands, and we're gonna try to actually do a little bit more engineering as opposed to just kind of like vibe coding and slapping it in there. So let's get started. All right, so here's our new project and well, our old project. So we did this before. This one was called the Aware Koala. So I've copied that over. When we did that, we did it inside a dev container, using some other stuff. And I want to go back to, I'm going to actually use Code Forge this time to do it, to do all the development and stuff too. But you'll notice in here, we have a CMake lists file, but and a flash thing here, but we don't actually have like a README that says, hey, this is what we're doing. So the first thing we're going to do is we're going to try to generate, not even try, we're going to generate a README from this. So let's start by putting a Claude directory in here. And then I'm going to put a directory into there called commands. And these are the commands that you have access to when you bring up either Claude Code via the CLI or via the VS Code extension. And I'm going to call something prime.md. So this is going to be our first command. And what I want to do is when the agent starts up, it's completely empty with new stuff. So what I'm going to do is I'm going to give it a command that I can run that will give it kind of the lay of the land. It'll tell us this is what's actually happening in this repository, in this project. So the name of this command is called prime gain and overview. So, and I've tried a few different things. I really like what indie dev Dan is doing, where he's got kind of a description of the thing, then it's got like a set of inputs. So we have like variables, and then we've got a workflow, and then a report. Now, that's the way he's been doing it. If you go to like Claude's official documentation, they've got a little bit more. They've got kind of a metadata section at the top and some other like um, context, way of filling out the context, and then kind of instructions or what to do kind of stuff. So there's a lot of different ways of doing this. It turns out, and it's interesting because as a developer, as a programmer, I'm so used to my deterministic, like, okay, set this thing here, set this thing here, set this thing here. With this non-deterministic AI thing, you don't like you can do it your way. You can do it a little bit differently. You can have different ways of interacting with it and getting similar results. At the same time, you can try prompting it the same way over and over again and get different results that way. So like there's a lot of different ways of cooking this frog, if you will. So variables, we don't have anything that's going to come in from the outside on this one. What we're going to do is we're just going to say, okay, the workflow, we want to do a get ls files to understand what the files are in this project. And then two, we would have like a readme, but we don't have that right now. So what I'm going to do, and then report, we're just going to say, print out a concise. So I wanted to print out just a summary of what you've learned about the project. So when we bring up Claude now, I can say prime, and we'll see what happens. Okay, so it did a get ls files, and it got a bunch of stuff. Well, now it's reading a bunch of other files, which I didn't ask it to do. And oh yeah. Okay. So it's looking for a readme. It's doing this other stuff. So here's another thing that we can put in here. This is like, okay, one of those things, like it's doing what I asked it to do, which is gaining an overview of the project, but it's not doing what I told it to do. what I meant for it to do, which I meant for it just to right. See, look at that. That's pretty good though. So it figured out there's a hello world, there's an LCD display, there's a build system. So we're gonna put in important. So if I tell it to run a command or open files, that's the only things I want to do. I don't want you to go do anything else. Okay, so that's what the prime is going to do. But since it did that, which is what I wanted to gain an overview, and we don't have a README, let's create later. So I'm going to take what you've understood about the project and then create a README based on that to get up to speed quickly on this project. And then what we'll do is once that's done, so that when we prime, we'll ls the files just for giggles, and then we'll create this README, and we'll say, yes, allow to write. All right, so here's the README now. Peripherals, project structure, hardware, click the icon, embedded firmware project, featuring an animated LCD display, HAL drivers and middleware. See, so it's got all that CMake modules for the STM32. Hey, pretty good. Peripherals configured, build system. Awesome. This is a typical STM32 CubeMX generated project structure with custom application logic in the core directory. Sweet. So now we close this and open a new one. Okay. Once again, brand new. So nothing in it. I click on prime. And what it's going to do, not a Git repository. Okay. This isn't. Oh, but it didn't. It's not listening. Okay. So I just did a find. All right. Well, that's not bad. It substituted out a Git ls files for a find. But notice it didn't actually open any of those files and read them, which is good because what I wanted it to do is I wanted to get the README file, which is what I said in here, and I wanted to get a directory structure. So there you go. Awesome. So now we've kind of primed the environment. A lot of times, what you've seen me do before, well, maybe you've done before, is like you're trying to prime it and say like, okay, be this kind of thing, and then do this kind of work, like, and kind of get that basic understanding. So what we've done is we've taken that like that way of like trying to get that basic understanding, and we're taking it out of the prompt, the specific prompt that you're giving it, and put it into a slash command so that you can do it separately and it'll be the same every single time. Okay. And what that slash command will then do is then everything that we've just, all that workflow, everything we've just done is now part of the context window that your AI is working with. So muy bueno. All right. What do we want to do now? Let's see. So the whole point of this is to click the icon. So we want to have an icon that goes on here. And then it takes it off. So let's put together a plan for updating this screen. It seems like a pretty simple thing to do, but I really want to kind of focus on more of the engineering standpoint. So what we're trying to do is we're trying to update this repository, this baseline, this code base, with a different piece of code that's going to put an icon on the screen so that and enables me to click it. Because right now, what it's doing is it's doing a hello world and it's printing hello world. So I'm going to attach my board here just so we can show you what it's doing currently and what this project's doing. Come on, where is it? Go. All right, so then I'm going to say build. Oh, before we get to that. So I don't have the development environment set up yet, but I do have the development environment set up. And what I need to do is initialize Code Forge in this repository. So we have to actually create the Docker image and initialize the project for Code Forge. So it's downloading now. We'll let that go. But then what we'll have to do, okay, so another couple of things that we need to add to this project to make sure that we're ready to do this. So we've got the development environment has not been set up on the host file system. So any compiling, running unit tests, debugging unit tests should be done using the CodeForge CMake MCP. And so what CodeForge has inside of it is as a Docker image that has all of your development environment, your development tools inside of it. So it also has an MCP server, and MCP is called a Model Context Protocol. I think that's what it stands for. So it allows the AI to reach out and make function calls over specific protocol, so JSON calls basically out to some other server. So a lot of times MCP servers are gonna, like, you want to interact with Jira, you want to interact with GitHub, you want to interact with Slack. Um, so there's an MCP server that comes with that, and then then the AI can then, once you set that up correctly, you've got that communicating from the AI to your external service. So we have one of those for the Code Forge development environment as well, so that the AI, when it wants to go and actually compile the software, it'll compile the software inside the MCP server, not the MCP, but it'll use the MCP protocol to communicate with the CodeForge Docker image to then create, it'll run those commands in there. So we got to get that set up after that. So let me go and grab the MCP server configuration for that. All right, so this is the configuration that we spit out for the MCP server. We're telling it to run the Docker image, and then it'll actually run the MCP server, which will be listening over there. So let's go here. And I don't think I'm going to have to, but we'll see. We might. Let's see what I do. Claude. Yes, I want to try execution allowed by. Okay. Click the icon. Okay. /MCP. Connected. Enter to view details. Enter. Connected. View tools as a run command. Okay, so this is working. It's got a description. AI assistants need to use this tool for all embedded development operations, including building firmware, unit tests, debugging, static analysis, and fuzzing. Properly contained environment. It's got the build tools. It's got the correct tool chain involved, build tools, test frameworks, analysis tools, et cetera, et cetera, et cetera. So common usage patterns. Neat. All right. So that's there. All right. And actually, let's just stay in this, because I know that sometimes with the VS Code extension, I don't even know, it doesn't have a good way of like viewing the MCP servers this way. So we'll just let that alone for now. Okay. So we've got the MCP server set up. Our code force has been initialized, so it's there. It says update image. Okay, there we go. All right, so we'll go here and we'll say prime. Yep, prime the project. Okay, so it read the README, listing out the files. Okay, so it's got an idea. All right, so there it's go. So now it's primed up and ready to go. And you'll see, because we put in here, make sure the development environment is on the host system. Per the workflow instructions, compilation unit tests should be done through the CodeForge CMake MCP, not on the host file system. Okay, so I'd like to build. So the build should go into the CodeForge MCP, is the CodeForge, the Docker container that it's going to put up, and then it should flash it to the board. So we'll see what happens. All right, so yes, do I want, yes, and don't ask again for run commands. Yep. Okay, it failed. So you see that it failed. We'll have to see why it's failing. Okay, the next step will be there. Missing includes, build using the wrong compiler. It's using standard GCC instead of the ARM cross compiler. Okay. Dun, 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 dun. Now this is possible because I was doing this in a completely different development environment before. So I copied this out. Let me fix the compilation and use and reconfigure the correct tool chain. Fabulous. So it's converting, it's upgrading it for me. It's fixing it already. Sure. I'm gonna let that go. LSP provides code intelligence, like go to definition. So the stage that it's on is in reconfiguring CMake with the ARM tool chain. Let's like zoom in on this a little bit more. Okay. Okay. So it's found ST flash. I don't know what I was doing. So and the problem I have with this interface, I have a harder time seeing what it's actually doing. But okay. Flash bytes. Okay, looks like it is flashing the firmware. Let's see. Head down to view. Running in the background. Insert a view. Attempting to write. This is taking a lot longer than I was expecting it to. Waiting for task. Waiting for task. Well, the light is still flashing a bunch. So maybe it's doing something. Attempting to write. If you can see that, but it is flashing quite a bit. Okay, so it's hanging. Interesting. So it ran STMFO probe. So it's killing it now. You'll see that this one's still in the background here, waiting for task. Let's see. Warning, transfer error, timed out. So it's got two different. Cool. So it's killing something. Which one is it killing? Okay, it killed the flash write and it killed the probe. Okay. So we're gonna do this. Let's do manual flashing instructions. I don't want to do that. So let's see, board connections. As soon as properly connected uses the USB, is in the correct mode, not held and reset. That's true. I did not hold on the reset button because that's the black one. The black one. So that's not being held down. USB cables should be fine. Other software. I don't think I have anything else open. Okay. So let's try doing, yeah, let's use ST flash and reset at the same, reset the board. I've seen that before where it's like you had to reset it in order to get it to actually work out. Okay, but it's not timed out, timed out, timed out, timed out. Okay, let's stop. Let's stop. Stop. Okay, we're gonna unplug it and plug it back in. There we go. So maybe it'll work this time. ST flash dash dash reset. Boy, it is still struggling. It's still trying to run. Yeah, it's stuck. Okay, so we've interrupted it at this point. K to kill. There we go. K to kill. All right. So what if I bring open a new terminal here? How do I probe again? Why don't you tell me? What did you tell me to do? Option 1, option 2. Yep, kill all. They did all that, did all that. So go ahead. Process is cleared. STInfo, STUtil. Okay, so that's working. So maybe I'll leave that. Okay. System profiler. Let's try that. That's fine. Go try that out. SBUSB data type grep. What happened? Didn't appear to be detected. Simpler USB check. IO reg. Wow. Okay. Yeah, go for it, buddy. Okay, you got something there. Oh, but it's too verbose. Yeah, let's try again. Connect under reset. Reset. Okay, go for it. Oops, something flapping on the board. Alternative flashing. Close conflicting. Board power. LEDs are on. Check to see the ST-Link. Okay, so the ST-Link connection is working. The flashing should be quick. So I'm going to unplug this, plug it back in. Hopefully I didn't break the darn thing. All right, what does STInfo probe give you? Perfect. It's now detected. All right, but then it failed. Cannot connect to target. Connection under reset. Try again. Yeah, but we just went through the same process. And then it flashed on there again, but then it said soft reset failed, timeout. I mean, okay, yeah, ST flash erase. There we go. Cannot connect to target. Okay, hold down the reset button, the black, and run this command. Okay, so I'm going to hold down the reset button. And then, okay, and the light's a little flash in there. Keep holding it, run this command, keep the button pressed. Waiting for task to complete. My fingers are getting tired. Let's see. The LED is just, it looks going nuts, going back and forth. I don't know if the camera's picking that up. It's a whole minute now. Still going. Yeah, something's wrong. Okay, killed it. I don't know that I have the STM. Yeah, I don't have the Cube MX. I don't have the Cube Programmer installed. So, man, other command line options. The LED light. That's really well, and this is the thing. Like, it can't see the board, so it only knows. I'm gonna run off the internet. Yeah, I don't have OpenLCD. I'm gonna try a lower frequency. There it is. There it is. So if you remember, hello world, 1, 2, 3, and so it's counting up. So every second it counts up. And then after 10 seconds, it changes the colors on there. Success. Firmware success. Woof. Okay. We got it. 20, 21, 22. Yes, it is. Thanks. Okay, so we're gonna close this down. Because if we look now, which so we've used 63% of our context. Most of it has been messages back and forth with us. They've got an auto compact thing that can happen, but we've used up 63% of the. So like I don't want to go any further in this session. So what I'm gonna do is I'm gonna close out this session. I'm just gonna create a new one. Okay, and we're gonna do what we did invalid version. I just went through this. I literally just closed it. What happens if I okay, what if I type this? Manage MCP servers or MCP status. Okay, so that's there. All right, well, we'll try to use the VS Code one now. Slash prime mustering transmuting. Another thing that you really want to do, which we haven't done, is to make this a Git repository so you can actually see the changes that have been made to the files that you're looking at. So I really have no idea what changes it made to fix the build because I don't have it's not a Git repository. So let me do that first. And I'll do it myself. All right, we've got at least the initial commit here. So now let's go back to our VS Code extension here. So we got a summary of the project, got a pretty clean slate. We know that it says hello world right now. What I want to do is I'll bring in a couple files in to this repository. Okay, I'm just going to dump them in here. I got two code forge pictures. I got one with the yellow orange circle, one without. Okay. So what I want to do, as we're thinking about this, we'd like to just kind of update this project with this. So we'll try a simple prompt. Maybe we can do this in just a single one-shot prompt. So we got a pretty simple prompt. So we're going to say to update this project, instead of printing hello world, we want to display the orange Code Forge image, and then that's over here. So we've got the orange one. And then when their user presses their finger down, they should turn off the orange one and replace the other one and then pick it up to the other way. So let's see what this is going to do. We've primed it. We've given it a simple LCD. Help you understand the project display images and respond to touch input. Okay, so now it's going to break up its to-dos. All right. So it's found the two images. All right. Let's see. What's it looking for now? Touch controllers. Okay. Touch controller initialization. Okay. So it's looking for, all right. Now it's going to convert the images. And I've seen it do this before. It actually creates an IPython script to convert the images and then generate a C array. So yeah, we'll see how that goes. Let's see, main.c, see if touchscreen initialization is already there. Oh gosh, I hope it is. Perfect. So it's adding this touchscreen.h. Oh, interesting. Orange image. What does the convert images do? Oh my gosh. Okay. Neat. All right. Yeah, I want you to do that. AppLogic.c. Draw image. Okay, so it's actually leaving everything. It's just calling, it's still calling our app logic init. Okay. Okay. Initialize back color, red and white. Okay. Display the orange image initially. All right, let's see. BSP sources are included. Need to add the FT5336 touch controller component source. All right, so it's updating the CMake file. Build and verify the firmware. Super cool. All right, so it's going to make turn code 0, build succeeded, generate the binary and hex. Okay, run it through the MCP again. Verify the build by checking for any warnings. Okay, so it did the ARM none EABI size. Okay, successfully updated display. All right, flash it. Hold on, stop. Don't use. Okay, so don't use the MCP to flash the board. Just use it on the host computer. The flashing tools are on the host computer. Why are you copying it? Whatever, it's fine. Go ahead and flash it. Okay, the light is flashing. Yep. Reset, wait 2. Okay, reset. Now it's white. And then it's going to write it. Okay, now what? So I'll click the reset button and see what happens. You promised. You promised. Okay, the orange Code Forge logo will be displayed in the center of the LCD when you touch the screen. Let me try the reset button again. Okay, see if I press the reset button, it turns white and then turns black again. And then I touch the screen. All right, so we're going to have to. All right, I will give you one chance to fix this. Okay, so the board is blank. When I click the reset button, the screen goes white. And when I release it, it goes back. Okay, so this is the black reset button. Pressing that again. I see the issue. The image arrays are defined as const, which means it stores in flash memory, and the pixel by pixel drawing is somewhere else. Pixel by pixel drawing is very slow, is inefficient for this. Let me rewrite the code to use a direct frame buffer access will be much faster. Sure, buddy. Okay, it creates a frame buffer. Let me check the actual file content and rewrite it properly. Okay, it flashed white really quickly. Okay, so erase, sleep 2, and then write it. Okay, and it's flashing, the little LEDs flashing there. It's like it's taking its sweet time though. This is not continuous. Earlier it was just a continuous. Perfect. The firmware optimized image drawing has been flashed successfully. All right, I'm going to try the black button again to reset it. Okay, and I'm afraid. Okay, so it's on there. I it's I just I mean it's not orange. So but I just it's doing it's do, all right, well let's look. Let's just look. Let's just look at what it did. I'm just wow. Okay. All right. All right. All right. That's fine. That's fine. All right. So let's look at what it has done in this thing here. So we've got, come on. It added the ftf336 star.c. All right. So it figured that out. Updated my app logic to include the touchscreen. Converted the hammer into a C file. A bunch of stuff. Like, look at this. There's things there. I don't know. Maybe it's grayscale. I don't know. I don't understand how this works. Um, so yeah, that's fine. There's orange. There's the not orange one. So those are the two. App logic added a draw image function into it, and then it calls it in the app logic here. So it sets the whatever, and then actually draws the image. I'm just shocked. Shocked, 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 shocked. And then it is touching, it draws the image one way, and then it goes back and forth. So that actually works. I created these binaries and hexes over here, and then so I think I can delete these 4 things, and then that's the change. It actually did it. Okay, so we got it there. We got it there. Now I think a lot of it was setting up actually the getting it to the right context, getting it in an environment that can actually survive and thrive in is the big lesson, the big takeaway I have today is that um yeah, it's capable of doing this. It's you just gotta gotta prep it for it. And that prompt stuff is really important. So we might come back around next time and keep messing with this thing to see if what we can do next. But that kind of filling the context window with the appropriate amount of information so that it has it is really key. Is really key. So, all right. Thanks for watching. And yeah, get your code in the forge. See you next time.